Namaste. Welcome to Indian Knowledge Systems Primer Course for Children. In this session, we will look at the Indian Decimal Place Value System. Numeral system. A numeral system typically has a few symbols and rules on how to use those symbols to represent numbers. We are all quite familiar with how numbers are written today, right? However, have we thought how numbers came to be written in their current form? Let us look at how different civilizations designed various numerical systems. We will see that for a large numbers, many of these systems were not very useful. And then doing arithmetic operations with this became very difficult. That way, we shall be able to appreciate the Indian number system. We studied tally marks in our schools. Tally marks were mainly used to keep count of things. Here's an example that totals to 18. We can see that a vertical line is drawn for each number from 1 to 4. Then it is crossed to represent 5. Like this, we can write sets of 5. But just to write 18, it takes this much space. Now imagine if you have to write 3574. It's very difficult, right? So, this primitive system is not very efficient system. We will see that all other ancient civilizations had created systems that were just extensions of the tally mark system, but with different symbols. Babylonian and Egyptian are some of the most ancient number systems we know of. Let us look at how they were designed. Babylonian numeral system. This system is known as the sexagesimal system. What does that mean? This means that it is a base 60 system. It will have symbols from 1 to 59 and then repeat those symbols by grouping them. What we see here is an artistic depiction of a Babylonian clay tablet with numbers. Babylonian numerals were written in the cuneiform script. They used a wedge-tipped reed as their stylus. They made a mark on a soft clay tablet like this, which would be exposed in the sun to harden and create a permanent record. Tablets with these markings for numbers have been dated to 1900 to 1800 BCE. Now see, this is the symbol for 1. It is repeated twice for 2 and then thrice for 3. Then it's grouped as 3 and 1 is added for 4 and then so on. It goes till 9. Now this is the symbol for 10. It is repeated twice for 20. It's repeated thrice for 30. Then it goes on till 50. For 60, 10 is repeated 6 times. Or 1 is written on the left to say one set of 60 is over. Then for 70, write 1 to denote completion of 60. And to the right, we start writing 10. Now we get 70. The same way for 80, 90 and so on. See, this is how it was used. This table is based on a clay tablet from 18th century BCE. This has the account of the cattle population. Look at how each number is written. For 61, we write 60 and 1. For 84, we write 60 and 20 and 4. So, when this is summed up, we get 120, 20 and 5. So, the sum total would be 145. The same way, we have 60, 30 and 6 to represent 96. We have 60, 40 and 5 to represent 105. So, when we add this, we get 180 plus 20 plus 1. Note that here 3 ones represent 3 60s, which is 180, and then we have 20 and 1. This is how the Babylonians designed their number system. We can see that in addition, carrying over is very difficult. Now, Egyptian numeral system. The Egyptians had a writing system based on hieroglyphs from around 3000 BC. What are hieroglyphs? Hieroglyphs are little pictures representing words. These minute, complex and decorative symbols were mainly used in memorial inscriptions on stone monuments and tombs. They had separate symbols for 1, 10, 100 and so on, up to 1 million. Now, let us look at an example of how it was used. Here, the number given is 47,209. But just to write this number, it takes this much space. We must write the symbols of 10,000 4 times. And then we have 4,000 and 3,000 to represent 7,000. Then we have to write 2 hundreds and 9 ones. Imagine you had to do homework in math like this. Just to write the numbers, it will take a long time. Because elaborate drawings of symbols take time, later they developed a hieratic script for penning down more details. Evidences are there for its usage from 12th century BC on something called papyrus. What is papyrus? Papyrus is a material prepared in the ancient Egypt from the stem of a water plant, used in sheets throughout the ancient Mediterranean world for writing or painting and also for making things such as a rope. Now, the Greek numeral system. The Greek system is an acrophonic system. Acrophonic means that the symbols for the numerals come from the first letter of the number name. Here are the symbols for 5, 10, 100 and 1000. Here is an example for 3,807 units of their ancient currency. They have written 3 times the 1000 symbol, and then the 500 symbol, and then 3 times the 100 symbol. This gives us 800. Then they have written the symbol for 5. Then the symbol for 1 2 times. This gives us 7. So, the total value would be 3,807. In this system, 5 is an auxiliary base. That means for writing 7, we can write the symbol for 5 one time followed by 2 times the symbol for 1. This saves some more space instead of writing 1 7 times. All this is still not very efficient to write big numbers and do arithmetics with. Later, the Greek used 27 alphabets like alpha, beta, gamma, etc. to denote numbers. They grouped the 27 into 3 and the first 9 denoted the 9 units. The second 9 denoted the 9 multiples of 10. Then the third 9 denoted the 9 multiples of 100. This is like a shorthand system for the decimal place value system. Then comes the Roman numeral system. Roman numeral system for representing numbers was developed around 500 BCE. As the Romans conquered regions across Europe, their numeral system spread throughout Europe. Roman numerals remained the primary manner for representing numbers up until 14th century majorly throughout Europe. Until then, it was the most prevalent system. We still study this in our Indian schools. We know the system very well, right? Here are the symbols that are given by the Romans for 1, 5, 10, 50, 100 and 1000. In this system, writing I to the left of V means 1 less than 5, that is 4. Writing I to the right of V means 1 more than 5, that is 6. This is still not a very effective system to do calculations. See, here 1988 is written in this big fashion. Imagine doing multiplication and division with these numbers. Very tough, right? They had to do repeated addition and subtraction to do multiplication and division. It's very complex and challenging. It is indeed the decimal place value system developed in the Indian civilization that has been adopted by all today. Where are its origins? Without writing it as symbols, since we had an oral tradition, the place values were available as names from the Vedic times itself. Here is an example from the Rig Veda, which has the number 3339 in it. The date of the Vedas is much debated. It is at least as old as 2000 BCE. And the number system should have been well known way before that as well. These unique 10 symbols for number representation in the place value system, we do not know its exact origin in the written form. All we can say is that the Kharoshti and the Brahmi inscriptions were prevalent during 250 BCE. These scripts seem to have numeral representations in them. The numerical symbols for the Nagari script, these which are widely prevalent now, were developed from the Brahmi numerals. We do not know where the Nagari numerals were exactly formulated. This is the evolution of number system. This is probably how the numbers have evolved across various scripts until now. There are many variations, but this gives the general idea as to how the current form of numbers came to be. The Indian place value system was adopted by Arabs in the 9th century CE. From there, it spread to the countries of Africa and Europe. Since Europe got this numeral system through the Arabs, they first called it Arabic numerals. Later, it was called the Indo-Arabic system. Now, it is recognized by many scholars as the Indian decimal place value system. In this system, the digits are placed in specific arrangement of the units, tens, hundreds and so on, such that each number's position conveys what place value it belongs to. Here is an example. We have 347. It means 3 hundreds plus 4 tens and 7. So, 300 plus 40 plus 7 gives us 347. Another example is 902. This is represented as 9 hundreds plus 0 tens. We do not have any tens, so 0 tens and 2 units. So, this gives 900 plus 0 plus 2, which is 902. We have all heard the name Aryabhatta, right? Aryabhatta is one of the India's most celebrated mathematician and astronomer. In 499 CE, that is more than 1500 years back, he wrote a text in Sanskrit called Aryabhatiya. In it, he has defined what is the decimal place value system and what are the names of the positions till 10 to the power 9 in a verse. Now, let us look at the verse. Ekam cha dasha cha shatam cha sahasram ayutaniyute tatha prayutam kotyarbudam cha vrindam sthanat sthanam dashagunam syat. What is the meaning of this verse? Sthanat sthanam dashagunam syat. It means from one place to the other place, it is a multiple of 10. And what are the place values? Ekam, dasha, shatam, sahasram, ayutam, niyutam, prayutam, kotihi, arbudam and vrindam. This has been represented in the table. Here, 1 means ekam, 10 is dasha, 100, shatam, 1000, sahasram, 10,000, ayutam, 1 lakh, niyutam, 10 lakhs, prayutam, 1 crore is kotihi, 10 crores is arbudam, this 100 crores is vrindam. Now, for our practice, let us try to identify the place value of the underlined digit. First, we have 4152. The place value of 4 would be, first, here it's ekam, dasha, shatam, sahasram. So, the value of 4 is sahasram. Next, 817. Here, the place value of 8 is shatam. Then, 30172. The place value of 0 here is sahasram. Eight and 5. The place value of 5 is ekam. 65724. The place value of 2 is dasha. Here are few more examples. You can pause the video and try to find the place values on your own. In ancient Indian mathematics and astronomy, large numbers too have been dealt with. How about numbers greater than 100 crores? Yes, we have the names for many more place values. Bhaskaracharya, who was born in 1114 CE, in his very popular mathematical work Leelavati, has given names of place values for even this big number, that is 1 followed by 17 zeros. Let us look at the verse. Ekadashashata sahasrayuta laksha prayuta kotayah kramashah arbudamabjam kharvani kharva mahapadma shankavastasmat jaladhishchantyam madhyam parardhamiti dashagunottara samyaha sankhya sthananam vyavaharartham kritaf purvaihi. What does Bhaskaracharya tell here? He says, sankhya sthananam kritaha purvaihi. That is, the values of the numbers are coined by our elders. And dashagunottaraha, which means the place value of a number is 10 times the previous number. Now let us see the place values. Ekam means 1. Dasha 10. Shatam 100. Sahasram 1000. Ayutam 10,000. Laksham is 1 lakh. There Aryabhata used Niyutam. Laksham is just another word for Niyutam. Prayutam 10 power 6. Kotihi 10 power 7. Arbudam 10 power 8. Abjam 10 power 9. There Aryabhata used the word Vrindam. Abjam is also the word for Vrindam. Kharvam 10 power 10. Nikharvam 10 power 11. Mahapadmam, that is 10 power 12. Shankuhu 10 power 13. Jaladhihi 10 power 14. Antyam 10 power 15. Madhyam 10 power 16. Parardham means 10 power 17. All this comes to show us that our civilization has developed and for long used the decimal place value system. 0 alone isn't India's contribution to the world of maths. It is the decimal system of number representation powered by the 10 symbols of 0, 1, 2 and up to 9 that has revolutionized the world of mathematics. All of the math and the arithmetic methods that we learn today are based on the sound system, which is very efficient. You are welcome to also play around and try creating your own number systems. Remember, a number system is made of symbols and rules. Come up with your own system and see how you can add, subtract, multiply and divide digits. You could also try to perform arithmetic operations with the Roman numerals and log the time taken. Compare it with the time it takes to complete the operation in the Indian place value system. This would help us appreciate the Indian decimal place value system. Thank you. Dhanyavadaha.